Now, if you can still see this red thing here, it means you have not yet subscribed. So you just have to click it so that the next upload, you see it is still red. You have to click it so that if I upload the next video, you'll be informed. Click the bell icon too so that you get a notification whenever I upload a new video. Thanks for watching. Don't forget to subscribe.
Sets. Now, let us consider what sets are and how you can revise them for this year's WASSCE exams. So, we have the perfect squares 1, 4, 9, 25, 36, and so on and so forth. Now, if you take the square root of this number, you get 6. This is an exact value. If you take the square root of 25, you get an exact value. The same way, if you take the square root of 9, you get an exact value, which is 3. So we have some numbers that if you take their square roots, you don't get exact values like this. For instance, if I take the square root of 2, I get 1.4 something, something, something. Then if you take the square root of 3, you don't also get an exact value, you get 1 point something. So the numbers under this radical sign whose values are not exact are what we refer to as sets. So if you have square root of a such that we cannot find an exact value for it, then we say it is a set. If we have square root of b such that we cannot find an exact value for it, then we say is a set. So the a and b are positive integers. A and b are positive integers. So that is what we refer to as sets. Now let us consider some properties, some rules that will help us simplify sets. So if we have square root of a, we have square root of a times square root of a, this will give us a. So this is the first property. So you can just think of it this way: root a times root a. Anytime you have something multiplying itself, it is the same as that thing squared. So root a squared, and you know the square and the square roots are inverse operations. So this will give us a. Now the second rule, if you have square root of a times square root of b, to simplify this set, you just have to give the two sets one radical. So you give them one radical, then you multiply the radicand, that is the things that are inside the number under the radical sign. You just have to multiply them. So root of a times root of b is equal to root of ab. Then if you have m root a plus m root b n root b, and you are adding them because they are not like sets. These and these are like sets. These and these are not like sets. So this and this are also not like sets. But this time we are adding. So if we add unlike sets, we get the same expression. We get the same expression. So if you have like sets, so m root a plus m root a n root a, then we can add these like sets just like mx plus nx. So we can factor the root a and we obtain m plus n into root a. So the same thing applies if you have m root b plus n root b, you get m plus n root b. So the same thing applies to subtraction also. So if you have m root a minus n root a, then you get m minus n root a. If they are multiplying, the same thing will happen. So if you have m root a times n root b, you just have to multiply the m by the n, so mn, then you apply this property to root a root b, that will give you m root ab. So these are the properties that we are going to use. Then one last property is rationalization of the denominator. So if you have a set of the form A over root B, to rationalize means we want to remove the set from the denominator. So what do? We need to multiply by the set in the denominator, both the numerator and the denominator by the set in the denominator. So the set in the denominator is root b, so we multiply the numerator by root b and the denominator by root b. So this will give us a root b, then root b will give us b. So if we have a set of the form root a, root b, and we want to rationalize, the same thing applies. So this will give us root a, root b over root b times root b. So this is multiplication, and this will give us root ab over b. You could also get rationalization of the form, let's say n over m root b. So in this case, we still have to multiply by the set. So we get n over m root b times root b over root b. So this will give us n root b over mb. So mb. Now, someone will ask if I multiply by m root b. Fine. That is not wrong, but I guess that is going to make your numbers huge, which will simplify eventually to this. Now, we have looked at the properties, the rules that we're supposed to know to simplify sets. So let's take an example. So the first example is so we want to express root 2 plus root 5 over root 10 in the form a root b plus in the form a root 2 plus b root 5, where a and b are rational numbers, where a and b are rational numbers. So we can see that this set is having a set in the denominator. So the last example that, or the last property that we talk about, we'll hold here, which is rationalization of sets. So what do we have to do? We rationalize the set. So we have root 2 plus root 5 over root 10. So to rationalize this means we are multiplying both the numerator, which is root 2 plus root 5, and the denominator, which is root 10, by the denominator root 10 over root 10. Now when this happens, we obtain this, multiply this, so 10 into root 2 plus root 5 all over root 10 and root 10, which is 10. Now this will be equal to, now let's expand the bracket over here. So this root 10 will multiply root 2 and again multiply root 5. So we'll get root 10 times root 2, then plus root 10 times root 5 all over 10. So the next thing we have to do now is to simplify this. But before that, let's see what will happen. Root 10, there's a root 2 in root 10. So we want to aim at root A. There's also root 5 in root 10. So let's split this root 10 to something like this. Root 2 times 5, then times root 2. So the root 10 has now become 2 times 5. Then we also have root of 10, which is 5 times 2 or 2 times 5, then times the root 5 all over 10. Now this will give us root 5. We split the roots for them. We are going back. It's like we have root A times root B is equal to root AB. So it was like this. Now I want to write it like this. So root 2 times root 5. Root 2 times 5 will give us root 5 times root 2. Root 2 times root 5. Multiplication is commutative. Then times this root 2 over here. Then we have plus root 2 times root 5 times this root 5 over here. Now all over 10. So root 2 give us 2. So this will give us 2 root 5. Then root 5 will give us 5. So plus 5 root 2 all over 10. So now we split the numerators to get 2 root 5 over 10, then plus 5 root 2 over 10. So this will simplify to 2 goes here 1, 2 goes here 5. So 1 over 5 root 5, then plus 1 over 2, 5 goes here 1, 5 goes here 2, 1 over 2 root 2. So this is the same as 1 over 2 root 2 plus 1 over 5 root 5. So comparing these to a root 2, we have a to be equal to 1 over 2 and 1 over 5 to and 1 over 5 root 5 to b root 5. We have b to be equal to 1 over 5. So we are able to write the given set in the form a root 2 plus b root 5. So this is the next question we want to solve. We are simplifying 2 over 3 plus 2 root 2 plus 1 over 3 minus 2 root 2. Now if you see a question like this, what must you avoid? Don't rush to go and rationalize each of them first. To take your time, to consume your time, and if you're not careful, you mess up. So what you have to do is to study the denominator very carefully. Most of the times, they don't bring this kind of rationalization in core mathematics. So this kind of rationalization is in relative mathematics. So what they are trying to help you know, or what they are testing your knowledge over here on, is that they want you to use difference of two squares. So you can see that the two expressions are the same except for the sign between them. So the first one is plus, the second one is minus. So what you have to do is to collect LCM first. So if you collect LCM, something will happen. So LCM of 3 plus 2 root 2 and 3 minus 2 root 2 is 3 plus 2 root 2, 3 minus 2 root 2. This is the LCM. Now, this goes here. We have 3 minus 2 root 2 times 2. So 2 into 3 minus 2 root 2. Now this goes here. We are left with, when this comes here, this will go. We are left with 3 plus 2 root 2. So plus 1 times 3 plus 2 root 2. Now the next thing we have to do is to expand. So we expand this to obtain 6 minus 4 root 2, then 3 plus 2 root 2 all over. Now this is difference of two squares, so if you have a plus b, a minus b is equal to a squared minus b squared. So a now is 3, so we get 3 squared minus b is 2 root 2, 2 root 2 all squared. So we can simplify this further. This will be equal to, now we have 6 plus 3, that will give us 9. Now we have negative 4 root 2 plus 2 root 2, that will give us negative 2 root 2, so minus 2 root 2 all over. Now 3 squared is 9, 3 squared is 9 minus, now 2 squared is 4, then root 2 squared is 2. So this will give us 9 minus root 2 all over 9 minus 8. 9 minus 8 is 1. So 9 minus root 2, 9 minus root 2, supposed to be 9 minus 2 root 2, 9 minus 2 root 2 all over 1. So this will give us 9 minus 2 root 2. So the a is 1, the a is 9, so a is equal to 9. Then the b is equal to negative 2. So we are able to simplify that as required. So notice that after doing that, after collecting the LCM, the set has vanished from the denominator. Now I want to simplify this. So 3 root 75 minus root 12 minus root 12 plus root of 108. Now, what should you do? You can see that the sets are not like sets, so we cannot combine them, but we may be able to combine them if we simplify the radicand or the numbers under the radical sign. So what you have to check is to see if there's a perfect square hiding under the radical sign. So you can check by dividing by the perfect numbers by 4, 9, 25, 36, and so on and so forth. So you see the first one here, we cannot divide by 4, we cannot divide by 9, we can only divide by 25. So it means 3 root of 75. If you divide 75 by 25, you get 3. So this will give us root of 25 times 3. Then root 12. If you divide 12 by 4, you get 3. So this will give us root of 4 times 3. Then plus, you can divide this by 4, by 9. You can divide this by 9, but the highest, there's a bigger perfect number hiding here, which is 106. So which is 36. So we divide root 3, divide 108 by 36, and that will give us 36 times 3. Now we simplify further. So we split, if you have root A times root B, you get root AB. So as at now, this thing, root 25 root 3, root 25 times root 3, root 25 times 3 is the same as root AB. So we have to move backwards. So we get root of 25 times times root of 3 minus root of 4 times root of 3, then plus root of 36 times root of 3. Now root 25 will give us 5, so this will give us 3 times 5 root 3 minus 2 root 3, then plus 36 root 36 will give us 6 root 3. So this will give us 15 root 3 minus 2 root 3 plus 6 root 3. So 15 minus 2 is 13. 13 plus 6 is 19. So this will give us 19 root 3. That is the simplified form of the given set. Now let's take another example. So we have this question. We are supposed to simplify this set, giving our answer in the form Q plus P. So let's go. So this is the set given to us. Now this will be equal to, we are going to use the distributive property. So this will multiply the whole bracket here. So 1 times then this will also multiply the whole bracket. So this minus is this one over here. Then the same bracket. So what do we do next? We expand. So this time, this will be equal to, it's a 1 times anything, the same thing. So then we have this will multiply this, so we get minus root 3 over 3. Then this will multiply this, we get root 3 times root 3. Root 3 times root 3. And we know root 3 times root 3 will give us 3. Because we have root a by root a is equal to a. So let's go. So this will give us 1 over 3 times root 3 minus root 3 over 3, then minus 3. So we have similar terms, root 3 minus root 3 over 3, then we have 1 over 3 and minus 3. So this root 3 here, q plus p root 3. We are leaving the answer in this form. So we need to simplify this and this, and we simplify this and this. So this will give us 1 over 3 minus 3 plus root 3 minus root 3 over 3. So 1 over 3, the LCM here is 3. So we have 1 minus 3 times 3 is 9. Then plus this one to the LCM is 3. Then this is like over 1. So 1 goes into 3 times this, we get 3 root 3. Then minus root 3. So this simplifies to negative 8 over 3 plus 3 root 3 minus root 3 is 2 root 3 over 3. So we have A being equal to, we have Q being equal to negative 8 over 3 and P be equal to 2 over 3. So we want to find this. So what must we do? We just have to simplify the given set. We're given 3 minus 3 over root 2. So this will be equal to 3 minus 3. So you have to rationalize this second one. So times root 2 over root 2 times root 2. So this will be equal to 3 minus 3 over 2 times root 2. Because root 2 times root 2 give us 2. Then 3 times root 2 give us 3 root 2. So now we substitute root 2, which is 1.414214. So we have 3 over 1.414214. So this will give us If you simplify this, you get 0.87868. So this is the result of this correct to 5 significant figures: 1, 2, 3, 4, 5.
Now, if you can still see this red thing here, it means you have not yet subscribed. So you just have to click it so that the next upload, you see it is still red. You have to click it so that if I upload the next video, you'll be informed. Click the bell icon too so that you get a notification whenever I upload a new video. Thanks for watching. Don't forget to subscribe.